All right, this is the notes for Math 4, Section 2B, and we'll talk about polynomials and also their influence on piecewise functions, and we'll spend some more time with piecewise functions that are word problems. Now, I'm going to apologize up front because when I got into one of the further examples in class, and I suddenly realized that there is something that I needed to tell you about. I had forgotten that I had actually set this up to have just that discussion, and I didn't. So I'm going to be messaging everybody to come watch this and see what I really needed to tell you. And the issue is this, that we are learning that there are certain situations in which the endpoint behavior can be predictable. For instance, if we have a positive coefficient, whoops, I guess I need to turn my pen on there, a positive coefficient, like in this case, I have 1x squared, that's positive, and my exponent is even. So this would be the case whether it was x squared or x to the fourth or x to the sixth, whatever. My endpoints are going to be doing the same thing. They're going to, you've got roughly this kind of a graph going on here, and I just loosely drew that. But the thing is that as x is approaching negative infinity, y is going up. And as x is approaching positive infinity, y is still going up. And so they're both going to go up so long as the exponent is even, your degree, the highest exponents on there is even, and you have a positive coefficient in front. Now, when we change that to x cubed, we're still assuming that there is a 1 in front of there, which means the coefficient is still positive. But this time the exponent is odd. Oops. Is odd. And so we're going to have a graph that's roughly doing that and roughly doing that. And so that is -0, then y is also going down. And as x is going up, y is going up. And so you'll notice that with all 4 of these, the endpoints are going into different quadrants. The x squared was going up into the first and second quadrant. This one is going up into the first, but down into the third. And you're going to notice with the other two that we're going to pick up the other possibilities. If my coefficient is negative, that means that I'm going to be flipping my parabola. My exponent is still even, but I'm basically doing this. And so as x approaches negative infinity, y is going down. And as x approaches positive infinity, y is still going down. And again, we've not had a drawing yet that visited these 2 particular quadrants. And this is going to happen whether it's negative x squared, negative x to the fourth, negative x, and that could have some other coefficient, negative 3x squared, or negative 5x to the 10th. All of these, your endpoints are going to be doing the same thing because of these 2 rules. All right, you're looking at what the coefficient is in front. Is it positive or negative? You're looking at what the exponent is, the degree of the function. What is that highest exponent? Is it even or odd? And of course, with negative x cubed, instead of going up to the right and down to the left, you're going to be flipping that. And it's going to look like that. Now, our coefficient here is negative, and our exponent is odd. And we're also looking at the endpoint behavior. As x becomes negative, y is going up, And as x becomes positive, y is going down. So we literally have all four possible variations, which quadrant the endpoint is going into. So that, and again, if it's negative 5x to the 11th, that's an odd exponent and it's a negative. So it may have some wiggles and bumps in the middle, but you know what your endpoints are eventually doing. Now, we can use that knowledge here. I made reference to it without explaining it ahead of time. But since we have, technically here, x plus 2 times x minus 2 times x minus 2 times x minus 6, I'd asked in class, so if I multiply all that together, what kind of degree am I getting out of this function? And the correct answer was x to the 4th. Now, I don't see any reason there that my x to the 4th would be negative. I may get some negative numbers elsewhere along the way, but it's only the guy up front that I'm worried about. I'm simply going to get an x to the 4th out of this one. And so now here is where we look at the individual factors. That x plus 2, one of the rules that I taught in Math 2 and Math 3 is that whatever your factor is, your root is going to be the opposite sign. If I were to come over here and say x plus 2 equals 0 and solve, I'm going to wind up with x is negative 2. It's going to change to the other sign. So if I have x minus 2, that means I'm getting plus 2 as a root and plus 6 as a root over here. So here's the way I'm going to answer, is that I'm going to have negative 2. And because I only, well, I'll come back to the multiplicity in a minute. We'll answer that in just a second. What I'm looking at with the multiplicity is the exponent that goes with the parenthesis. For instance, the first guy, x plus 2, is to the 1. So he has multiplicity of 1. The second guy, x minus 2, has a squared above it, which means he has a multiplicity of 2. It is just like that. You just look and see whatever exponents they got, that's the multiplicity. Now, what the multiplicity means, how many times is this factor occurring when it's factored out like this? That would be like saying the x plus 2 happens once, it has a multiplicity of 1. The x minus 2, with a factor of 2, has a multiplicity of 2 because it happens twice in the equation. There are 2 of them. Now, here is a fun fact. When your multiplicity is odd, it does one thing, and when it is even, it does another. Our roots are at negative 2, and positive 2, and positive 6. And because we have a x to the 4th, we know that we're going to have something like that. It's going to have some wiggles in the middle, but because it's even, they're either both going up or down, and because it's positive, they're both going up. So I know that I'm going to start somewhere from here, and I'm going to go down somewhere like this, and I'm going to come back, and I'm going to come up here, but here's the thing about even ones, they only touch. And then we're going back up and out of sight. Odd ones go through, and the even ones just touch it, just kind of tap it and then go back the other way. They don't really cross through it. So that is the general rules as far as graphing some polynomial like that. If you can get it broken down to the individual factors, where it's just x plus this or x minus that, Not only will it tell you where the graph crosses the x-axis, but also you should be able to venture a guess as to the endpoint behavior. And we'll practice some more with those in the worksheet. All right, now for a couple of word problems to try and turn into a function. Here we have 3 levels of taxation. We have the first level where there's no tax, up to $15,000 a year. All of these taxes are expressed as percentages, so I'm going to express zero tax as 0.00. And it's impossible to have negative income. At least from a real world standpoint. You have money that you take in and money you spend out, but income is basically whatever's coming in, and so it's kind of hard to have a negative number there. So it's got to be bigger than 0. And up to 15,000, does that include 15,000? Yes, it does. All right, so that's the first one. And then the second one was income above 15 up to 30, assessed at 12%. And we're going from 15,000 up to 30,000. Whoops. We're going up to, so that includes 30,000. And then the last guy, we're doing 18% or anything above 30,000. Now, at some point I stopped in class and I said, but wait a minute, are these really constant functions? If the person that has $30,000 worth of income, are they really just paying 12%? 12% of what? Yeah. We need to say 12% times whatever their income was. So we're going to do that. And we're going to do that. And we're going to do that. So that is our piecewise function to model this situation. So when we get asked our next question, what of the person that makes 117,000? And so we'll say, well, 117,000 is certainly above 30,000. So this would be a blue situation. We're going to say 0.18 times 117,000. And well, I'm trying to remember what it was. And I do not know. That's right. I plugged my phone in. Well, we'll do it the old-fashioned way. Oh, I'll tell you what. I'll just pause and go get my calculator. Okay, and my handy-dandy calculator said $21,060. Okay. And on to the last one. This one was an interesting one. Let's see now, we start out with the formal language. And we first started by saying that somebody who makes $7 an hour, and X is going to be the number of hours, and Y is going to wind up being their paycheck. How much they're getting paid. So we're going to say 7 times the number of hours, and that is going to cover us for everything up through 40 hours. Of course, you can't have negative hours, not in the real world. Employers might want to do that, but that's just not right. All right, and then we look at, so what about when x is beyond 40? Well, we realize that there's kind of some piecemeal to this, because first of all, 7 times 40 is 280. So you're getting paid 280 bucks for the first 40 hours. But then after that, you're getting time and a half. Well, 1.5 times 7 is 10.5. That's 10.50 an hour. So you're getting paid 10.50 an hour for, it's not just X. I mean, if you were, let's say you worked 50 hours this week, you're actually earning only 10 hours of overtime, which means whatever X was, I'd have to subtract 40 from it and figure that out. Okay, I apologize for pausing, but anyway, I keep getting interrupted on this. We figured out that if you were working for 50 hours, you would have to say 50 minus the 40. That 10 extra hours is what you hit with the extra 10.50. Now, we don't want to put something that ugly and clumpy in here. We want to simplify it. So if we simplify it to say 280 plus 1050x, and then 10.5 times negative 40 is going to give us a negative 420. Yes. Now, so we're going to have 10.5x, and then positive 280 minus 420 is going to give us a minus 440. So, now we've got our equation straight. Now the fun part is establishing units for x and y. And, if we're talking about somebody working 50 hours, that's going to be $300-400. And so our y-axis is going to need to accommodate 300 and 400, whereas our x-axis only needs to accommodate numbers like 40 and 50. So I'm going to suggest doing the y-axis by 10, or by 50s rather, to where this is 100, and this is 200, and this is 300. And meanwhile, our hours, our x-axis would be by 10s, 20, 30, 40, and 50. All right, so now our first equation in red is going to have a slope of 7, and it's going to have an intercept of 0. So we know, well, I guess if you work 0 hours, you get 0 paycheck. So that does exist. Although that does say, oh, I guess maybe we do need to change that to less than or equal to, because it is possible to work 0 hours and you just get no paycheck. But if our slope is going up 7 and over 1, well, we're not playing with the same units here. Maybe if we thought of it this way, if I went up 350 units and over 50 units, that would be a slope of 7, right? So if I go up 350, that's going to be all the way up, and then I go over 50, that's going to be over here. So I'm basically talking about a straight line between these two guys. All right, so we do say that we're going to stop at 40, which 40 is going to put me right about there. After all, 40 hours times $7 is 280, so it makes sense for the 40 to go there, and we're going to connect with a straight line, as straight as Mr. G is capable of drawing, and then we can lose this guy. Now, at that point, we are switching over to overtime hours. If we had plugged in 40 into this equation, we would have wound up with 280 exactly. But now I will say this, the slope of 10.5 should be steeper than 7. I'm not quite sure how, because it goes completely off the scale. So, it's going to be going up further, but it should be, I need to make that appear more sharper than it is. That might do the trick. Because about the time you get to 50, let's see now, that's 105 plus 280 is 385. So it should be, somewhere close to 400 here. Anyway, that's a pretty close estimate for that. And I believe that is it for that set of notes.